Okay, for the last part of this, for each recursive formula, write an explicit formula. So the recursive formula, remember, is the three parts. So I've got the first part, the second part, and the third part. So as far as writing the explicit formula, what I need to know is it arithmetic or geometric. I need to know if there's a D or R, and I need to know a sub 1. Well, a sub 1 part is really easy because it's right there. It's really easy to find the D or R. I know if it's arithmetic or geometric because if I see the minus 12, I know that that's arithmetic because I'm subtracting 12 or adding a negative 12 each time. So writing an explicit formula, remember that's the a sub n is equal to a sub 1 minus 12 times n minus 1. And so this goes back to at the beginning when we wrote what the explicit formula was, and it's at the top of your page. That's all you're going to do. That's it. Okay, number 20. Okay, we've got our a sub 1. I can look at my equation and see that I'm taking a sub n minus 1 and I'm multiplying by 4/3, so that's my r. So looking at my formula up above, I'm going to write a sub n is equal to a sub 1 times r to the n minus 1 power. Okay, try number 21. Okay, I can see that it's arithmetic, so my D is equal to 1. I can see that my a sub 1, so I'm going to say a sub n is equal to a sub 1 plus 1 times n minus 1, and I'm done. Number 22, try that one. Sometimes because of the way the order is written, it's a little bit confusing, but this is my a sub n minus 1, and so that number right there, that's my r. That's all you have to do. Okay, the last part of this, the following heights are for the first 4 years after the tree was planted. So my a sub 1, where we're starting, that's 10 feet tall. And my a sub 2 is 11 feet tall, so after 2 years after it was planted, it was 11 feet tall. And so the sequence, is it arithmetic or geometric? So you think, well, we added 1, do you keep adding 1? Does it just grow 1 foot each year? And that's not the way it works. So I'm suspecting that it's geometric. So if I say 10 times something is equal to 11, I can solve that and find that it's 1.1. So it is geometric. My constant ratio is equal to 1.1. What is a sub 1? It's 10. So now you need to do a couple of things, right? The recursive formula, that's the one with 3 parts. Write an explicit formula, that's like what we just did at the top. And then we're going to answer some questions. So pause the video and write both of the formulas. So you're just going to follow the examples that you've done before. Okay, so for this one, since we've decided that it has an R, it's going to be a geometric sequence. So we're going to write the formula like that. So there's my recursive formula. You see, I just follow the pattern. Okay, it doesn't have to be hard. If you just remember, it's got those 3 parts, and you're just going to put in those little pieces. Now, an explicit formula, again, I know it's geometric, so it's going to be a sub n is equal to a sub 1 times r to the n minus 1 power. Okay, so you know it's an explicit formula if this one says n and this one says n minus 1. If it's recursive, then you're going to have the n and the n minus 1 as the subscript there. Okay, now 28 and 29, when would each formula be the most useful and why? So I want you to stop and think about, when would I use the recursive formula? When would I just take the previous term and multiply it by 1.1? And when would I want to use the second formula? So write a sentence about each one and then start the video again. So the recursive formula, the thing that I think of there is I would use the recursive formula if I knew how tall the tree was the year before. So if I said, oh hey, this year the tree is 27 feet, how tall is it going to be next year? I would just do 27 times 1.1 and I would find out how tall it was. So that's when I would use a recursive formula. So the recursive I would use if I know, if the year prior is known. So if I knew the one that came before, when would I use the explicit? The explicit is actually really good if you're trying to project for a certain point in time. So if I say, well, 15 years down the road, how tall is the tree going to be? Then I could use the explicit formula, because I could say a sub 15 is equal to 10 times 1.1 to the 15 minus 1 power, and I could find out how tall the tree was going to be. So the explicit is if I don't know the term that came before, if I'm just looking for any year. So not necessarily knowing anything that came before. Last question, if the pattern continues, how tall will the tree be in 12 years? So which formula do you want to use? What would you need to know if you were going to use the recursive formula? What do you need to know to use the explicit formula? So pause the video and find out how tall the tree will be in 12 years using whichever formula you think is the most useful. Okay, I don't think the recursive formula is going to be useful, because if I was going to use that, I would have to know how tall the tree was at 11 years, and to know that, I would have to know how tall it was at 10 years, and so on. So the explicit formula would actually be the most useful to me. And so if I said, well, if I want to know how tall it is in 12 years, all I'd have to do is write this, and then 12 minus 1 right there. I would put 10 times 1.1 to the 11th power in my calculator. And that gives me 28.53, and so round to the nearest tenth, so 28.5 feet tall. And that is approximately how tall the tree will be if it continues to follow this sequence.